In this video I'm going to show off this DIY hot wire cutter that I made. A video by a YouTuber called Schematics gave me the idea to work on this project, and I'll put a link in the description to his version of it. The advantage of using a hot wire to kind of melt your way through the material rather than a mechanical cutting is that you don't disturb the material, ideally. So this is good for things like foam and polystyrene. You can also effectively make zero radius cuts because there's not a blade with a given orientation that it wants to cut in.
Dad, Mom says to stop trying to give yourself cancer.
Just gonna get a little bit of cancer, Stan. Tell Mom it's okay.
So the frame itself is a simple steel welding project. We'll have to slag on there. I cut a slot in here, and actually that is a good idea because if you don't have a slot here, you're going to have some kind of protruding thing here, which will be a 3D printed part and therefore won't be as rigid. So of course, I'm not able to really produce perfectly level welds. These are the grand total 3D printed parts here. So this is the sort of pulley system I've got set up. The wire comes through here, and the tubing is in the center point, and then you can use the groove I cut in the tube, so this is very well supported. Here I just made myself some shaft clamps. None of this is particularly high stress. Here I just used some pulleys, timing belt pulleys that I had lying around as shaft clamps. The nichrome wire is connected via a terminal block. It's just one of these. It's just one of these standard terminal blocks, and I cut away all the plastic with a utility knife, and then you're left with the metal part here, and then I connect that to a silicone coated wire. It's important that the 3D printed parts, and indeed the metal that comes into contact with the 3D printed parts, is insulated from it, insulated from the nichrome wire, which gets very hot, and the terminal block, which also gets fairly hot by this silicone wire. And silicone is a good heat insulator, so that, and then the sort of thermal mass you have here, because this wire will perhaps get a bit warm from being adjacent here, and maybe it has its own resistance and so on. It helps kind of keep some distance. In my earlier attempts, I tried with a 3D printed part, and I had a bolt going through here, bigger than this obviously, but you can imagine, and then the nichrome wire just kind of hanging off it, and the bolt itself got quite hot. I think purely because it was in contact with the nichrome wire, and as you can see, just the radiant heat as well from the wire going through here has kind of melted this. The bolt kind of migrated due to the tension that was on it as well. So this is a no-go. Okay, and then there's not much else to it. So essentially I have this gripper here. I've got the wire running through this gripper, which is connected via a spring to this lever, and then that's mounted on the shaft, and then you just have a kind of over center to hold it in place. So that makes for a very convenient way to relieve the tension. May as well demonstrate this. The wire is just gripped by this little inset block here. So I've got a little inset here that just puts the wire through a kind of sine wave type deal to help grip onto it. Trying to avoid having any like pinch points or anything like that. The silicone is obviously extremely slippery, so you need good contact area, a fair amount of friction. So then the way the rest of this works is I just have some steel wire, and then that's just a convenient way to hook onto a spring. And then I've just got an aluminium extrusion. A wooden dowel or anything would really work for this. Here you can see the terminal block. It's the same situation, another silicone wire. I didn't bother with the ferrule on this one, on this side. Now, the case, because it's all metal, should be grounded. I have not grounded mine, but it should be. So if you make this, you should ground it. So that goes there. If you were to pop it up. So this is kind of, I'm showing you like how quick and easy it is to change. This is what I had available to me. Tighten that down. And as you can see, this whole panel is floating, so I need to screw it down. It's kind of cool how that works. So we'll just do that. Okay, I'm going to put these screws back in. It takes forever, so I'm not going to film that. But you get the idea. Okay, so we pulled out all the stops now. I'm going to demonstrate how I use this thing. I don't have any fume extraction right now because it makes a lot of noise, so I'm suffering for my art here.
Just gonna get a little bit of cancer, Stan. Tell Mom it's okay.
Got the power supply set up. I haven't done anything with it. It was in whatever configuration it was before. So I'm going to turn it on. It's not connected yet, so I haven't connected the alligator clips. So we can see that the power supply is in constant voltage mode and it's at 14 volts. That's going to be way higher than what we need. So I'm just going to turn it into constant current mode by taking this all the way down. And then I'm going to connect it up. And then I'm just going to slowly bring it up. Bring it up to 1 amp, see what the thermal camera says. And yeah, it's already starting to show up, that's cool. Now I know from experience that it's about 4 amps is where this thicker material can be cut effectively. So I'm just going to go straight there. It's easier to just do this on a case-by-case basis, right? So what you want to do is just see if it's having an effect on the material, and yeah, it quite clearly is. You don't really want to burn the material, you just want to melt it, right? Because if you burn it, you're going to end up with a build-up of ash here on the wire, and then it's going to get progressively harder and harder, and the ash itself is a thermal insulator, so... Oh, it's a mosquito. You're going to get annihilated, buddy, if you fly into that wire. Actually, I'm fine with that. Slowly bring it up in constant current mode. And if you don't know constant current mode, it basically tells the power supply try to adjust the voltage to meet the current you specified. Heat dissipated is always proportional to current, not voltage, so that's why we use constant current mode here. So I've about halved, gone down to about 2 amps. And you can see we're not really doing much. Slowly bring up the temperature until you can cut your way through. What's happening there? Try that. Yeah, there we go. So it's quite slow. This foam is quite dense. And I can't remember exactly what this is, but I did check ahead of time that it's not gonna be too dangerous to cut this. Yeah. So you can bulldoze quite fast through, but then it's hard to control where the wire is going to go. At least that's how I found. Yeah, you don't want to hear that. Let's have a look with the thermal camera and see how we're doing temperature wise. As you can see, the silicone wire does heat up a bit. Let's see if I can bring back the hang on, I'm going to have to kill the recording. Okay, let's take a look and see how we're doing temperature wise. So as you can see, the plastic parts are not too bad. They're getting up to let's see the silicone wire actually for a start. Silicone wire is fairly toasty, so it gets up there. It's you know, at these temperatures, PETG is, you know, it's kind of the edge of where you can go with PETG. I'd say it's starting to soften, but that wire is pushing against the shaft before it comes into contact with the plastic. So the hottest the plastic seems to be getting about 40 degrees. So I carefully, yeah, that feels about right, something like that. So PETG can handle that. PLA, that's probably too far. It will start to creep. And yeah, you can see, and the wires themselves, they do get a bit warm. I mean, they are carrying what, 4 amps, so they will get a bit toasty. And here's a thermal shot of us cutting through some material. And if you hear a noise in the background, I just got a kitten, and she would very much like to come in and see what I'm doing, but she's not allowed, as you can imagine. Let's pull this out. So there you go. It's a wascally wabbit. I wonder if it's wild rabbit. It looks wild. No way, it looks tame. What's a wascally wabbit? Yeah. It's you. You're a wascally wabbit.